Hello, and welcome to part 2 of the series of tutorials that I'm doing right now. And it's by the end of the series, we're going to learn how to kind of do hard surface modeling with Rhino, and I'll show you all the tips and tricks that I know. But before we head on and then start actually modeling, I was thinking of actually 3D scanning, or rather using photogrammetry to 3D scan an existing object and use that as a baseline, a base geometry to model on top of, right? So during our video 1, or our first video, we looked at 4 different photogrammetry softwares, and we decided, or rather, I guess I decided, to use Regard 3D for the further, for this video, for instance. So Regard 3D, the mesh that we are going to get from this program is going to be quite messy, and I'll show you how to clean it up, how to topologize it properly, and how to get it in Rhino as clean as possible. I will be showing you 2 different ways on how to do it. One will be using Regard 3D, then Blender, then Instant Mesh, and then Rhino. And the other one will be just Regard 3D, Rhino, Instant Mesh, and then Rhino again. And I'll talk about Instant Mesh in a bit. It's a very, very nice little program. So Regard 3D wise, let me just open up my project, which I believe is right here. And I've already went through quite a few settings in Regard 3D, just trying to find the best possible output. And basically I can show you, let me just show you different, show points. So as you probably can remember from the previous video, if you haven't seen the previous video, I suggest just kind of going through it quite fast. It's going to be in the video description of this video. So just going through it quite fast, just to understand what I'm showing right now. But this is basically a point cloud that's generated from series of photos, and that's how Regard 3D deals with it, and then it densifies it, and it doesn't take that long. It's like a few hours to calculate. So it creates this kind of a dense point cloud, and as you can see, it's a robot, and we're going to, in the future, we're going to model on top of this robot, or other additions to it. So, but this is still a point cloud. You can see as I zoom in, it's all points. So it needs to mesh it, and that's where all of my testing took place, right? So I can show you the first iteration, which was not that great. Let me just quickly jump to the second iteration, which was better, like that. And then the last iteration, right here. It's going to take a little bit of time, but this is what we end up with. And I found that this is the best balance between noise and amount of detail, level of detail that we're left with, right? So we have a GUNPLA robot. Super. To achieve this level of control, or this level of detail, when I used Create Surface tool for densification, once I clicked it, here there are all of these different variables that you can change. And actually the only 2 that, or was it 3? I believe it was, yeah. It was these 3 that I changed. I didn't mess around with trim threshold, but I did change the depth, the samples per node, and point weight. So depth is basically how many polygons, how many surfaces will it generate from the points. The larger this number, the more it generates. So for the final output here, you can see I used 12, depth of 12. And it's quite quite dense. If I zoom in, you can see all of these polygons here. So I wouldn't suggest going beyond it, right? Especially for something small like this. Okay, so we have that going on. Now, when I look at it, so this one was 12, right? Why can't I write it? 12, hello? I can only increase it like that. And it's also an exponential growth of amount of polygons. So if you increase the slider even more, it's going to kind of crash your computer. Then we have samples per node. This is basically the smaller the number, the noisier the surface is going to be. The larger number will make it more and more smoother, much more smoother, but it will also start kind of messing up a little bit. So there's a balance to have here. And I believe in my case, the way I work with it, can I just hover my mouse? Yeah, there we go. So in my case, it's samples per node is 10. And the way I worked with it was, I believe first I tried 100 immediately. So I tried 20 and I saw that it messed up. With 20 it was way too smooth, a little bit weird. So I dropped it down to half that size, to 10, and it was okay, but I didn't know that it's the best answer. So I dropped it down by half the size more, and I saw that it's getting worse. So I jumped back to 15, was also worse, so I stuck to 10, right? So you kind of, by jumping around back and forth, you find a value that works best. And point weight, it's basically when you have a lot of samples, you want to reduce the point weight as well, because if you have a lot of points that are all over the place, like here, and you have a lot of weight on them, that means they will distort the mesh quite heavily. So you want to have a lot of points with not a lot of weight. And in this case, I do have quite a few points from this densification. So point weight, I chose to be 0.3 or 0.4, sorry, not even that, 0.5. Yeah, there we go. So these were the settings that I chose, and it might be different for you, but hopefully this kind of explains what these three do, right? Amount of polygons, how many steps or iterations does each point get within the calculation. More steps means more accuracy, but at the same time means more steps means more accuracy, but it also might mean that it's smoothing a little bit too much, and point weight just decreases the amount of bumps that you get. The less weight you have, the less bumps you have, but also it kind of smooths it out. Other than that, we don't care about textures whatsoever. So I'll just color it by vertices. Okay. So that's the surface that we get. And the problem with it is that, first of all, we have a lot of junk flying about and so on. So I need to clean it up, right? I will go to this surface 7, export surface, and actually I will export it here to my photogrammetry folder, and I'll choose OBJ, and I'll call this GUNPLA02. There we go. Hit save. Why didn't it save? Let's try again. GUNPLA2. Save. There we go. So now it's exporting it, and let's give it a second. There we go. It's done. So now I have it as an OBJ file, meaning that I will first show you the way I would do it, and later on I'll show you how you can kind of skip Blender for this step. But I'll open up Blender, and as always we don't need anything here, so I'll just hit A. Can I do, wait, this screencast keys? enable. Okay, and there we go. So now on the left-hand side, sorry, you'll see all of the key presses that I do. So I hit A, hit delete to get rid of everything. I go to File, Import, OBJ, and let me find desktop stuff, YouTube, OBJ, 164 megs, that's quite a few. Import OBJ. Let's wait for it to import. It's quite a heavy mesh. There we go. So it's somewhere here. Yeah, there we go. There it is. And I don't care about the scale right now. All I care about is getting rid of all of the unnecessary stuff. So first of all, I'll select it, and I kind of want to rotate it. So R, X, rotate it around the X-axis, G, Z, move it up. In the Z-axis, holding down the... Okay, so that's good. So now I'll select my object, hit Tab to get into the edit mode. And again, it's really heavy, so this will take a while. In the edit mode, I will start selecting stuff here and hitting delete, vertices. So just choosing vertices. You can either hit delete or X, whichever you want. Oh yeah, and it doesn't select all of the vertices, so I will choose wireframe, and then with here in the top right, with wireframe on, it will delete all of the vertices that you select. So it's going to kind of select it through and through. Delete vertices. There we go. Come on. Okay, getting there. Don't need all of that jazz. Don't need that jazz. Don't need that. Delete that. So I'm just kind of getting rid of all of the everything except the robot itself. Delete those and those. And I will not be reducing the amount of polygons for this particular mesh. I don't really care about that. I might smooth it out though. We will see. We will see if I need to do it. Delete vertices. So this is, you know, it's a tedious task, but it needs to be done. There we go. Delete all of that. Vertices. Get rid of that. And get rid of that. More that. Okay, so this is kind of done. There's some floating stuff around it, but that's fine because now I will tab, no, rather in edit mode, sorry. In edit mode, I'll press 3 to get into polygon mode. I'll hit A, I'll go to mesh, clean up, delete loose, no, sorry, separate. Let's go for separate by loose parts. So all of the loose parts will be separated from the main one. I'll hit tab to get out of the edit mode, select the geometry to figure out which one it is. It's the number 426 one, of course, is the last one. And here I have a lot of trash around it, right? So I'll just select all of it, hit delete, and now enable preview of the actual model without any trash. Well, there's still some trash though, but that's not too bad. We can kind of move on. So there are like three things that I want to clean up, and then we'll move on to the next program. And the first one is let's hit tab. First one is this guy right here. It's making me anxious. So I will just, let's say, select, this should be okay. Select this edge here, and then kind of let's zoom into it, go around here, and holding down the Control key, I will select an edge on the opposite side of the mesh, like so. And again, holding down the Control key, I'll select an edge here. So, oh, never mind. Come on, just extend. Just freaking extend. Why? I'm just trying to that was a bad idea. There we go, and extend until here. Hello? Why are you not cooperating? Oh, is that because, yeah, let's try it again. This is not being cooperative. So I'll select this edge on this side, and let's say, how does it look like? Maybe this edge on this side, and then this edge on this side here. So when you hold down the Control key, it will find the closest path between the two edges, between the previous edge that you've selected and the next one. So here I do it again, and then let's connect it like so. There we go. Okay, that's good. And then I'll hit delete, edges. There we go. We made some stuff happen. Or is it the edges that I want to delete? Sorry, now I'm Control Z. Let's try 3. Let's try with polygons rather than edges. I think this is gonna be a bit better. Like that, go around here, delete, faces. Yeah, this is cleaner. So yeah, removing it is better with polygons. Okay, then I will go to, again, mesh, separate, selection, nope, mesh, separate by loose parts, not selection. And this gets separated from our original mesh. Hit tab to get out of edit mode, delete this, select this guy, tab again to get back into edit mode. And now we have this, this hole here that we can fix by holding down the, is it the Control key? No, is it the Alt key? Yes. Not quite. Close, but not quite. Okay, so plan B is to select one edge around the, which is on the hole, and then go to mesh, select. Oh God. Oh, there we go. Select all by trade, select similar. So it's Shift G, and choose amount of faces around an edge, right? So we have already one edge selected, and by doing this, I will select all of the faces, all of the edges here, and also all of the edges here. So these are the openings, and I can do, I believe it's Control F, no, Alt F. So I can do Alt F, and just, it will automatically fill them in. Okay, so I have that done. Okay, that I really didn't want to have that blob sticking out. And now I'll do the same thing with this part. So this is the underneath areas where, you know, I didn't take any pictures. So it's all kind of interpolated and it's all messy. So let me actually select this edge. Or no, polygons, right? We're doing it with polygons. This guy, holding down the Control key constantly. Control. I just figured out that you don't see the keystrokes. Oh my god. Set origin. No. Origin. Let's do offset. Okay, so now you will see the keystrokes right here. I think. We'll see. Tab. Oh, now it's gone. I hate this. Anyway, doesn't matter. I'm telling you which buttons I press. So holding down the Control key, I keep pressing these polygons to make a loop. Then I hit delete, faces, get rid of it, mesh, separate by loose parts. And hit tab, select the stick, delete it, and now we have a hole in the crotch, so I hit tab again. Sorry, I first select the object and then hit tab to go into edit mode. Press 2 to jump into the edge mode. Select the edge, go to select, all by trait, nope, select similar. Yes, select similar. Amount of faces around an edge. There we go. Selects an opening for me, and then I just press Alt F to fill. There we go. Okay, so we're done with that part. Hit tab again, and this is what we end up with. Okay, so now before I export this again, I will just kind of move it into place. G, move it. GZ, move it. Top view, RZ, nope. Object, transform, no, object set origin, origin to geometry, so that it RZ rotates around its center point, and just move it to somewhere where I think is the center, and maybe slightly up. RX, kinda, is it fine? That's good. Yeah, that's okay. That's okay. Okay. So I have it rotated correctly, and now I will just, while I have this mesh selected, it has 300,000 faces, so it shouldn't crash. I'll just add a modifier to it. Set that. Let me just save it real quick to desktop. Just untitled, doesn't matter. I just wanna have it saved before I do this. So I'll add a smooth modifier on it. Doesn't seem like it did anything. Oh yeah, it's doing its thing. And I'll just smooth out the bumps a little bit. Can we have like 25 repetitions? It's still a bit bumpy though, but not that bad. Yeah, 25 seems to be a-okay. Or maybe we can do factor of 0.2 and then do 50 iterations. Okay, let's see how it looks like. Shaded smooth, shaded flat. It's a little bit bumpy, but definitely not a big deal, and seems to be kind of good. I would consider this to be good enough. So I'll just apply the smooth, and we have it going. Okay, so now let's export it. File, export, OBJ again, and let me go to my folder, and I'll call this GUNPLA from Blender.obj, export. That's good. And now in Blender, I didn't do any topology optimization, and this is because I want to do it in with this kind of new program that I found, which is called Instant Meshes, and you can download it from the internet. Just Google Instant Meshes download. It's free to use. It's a single file, and actually let me take a look. Instant Meshes. There we go. Instant Meshes, immediately the first link here. You go to the GitHub page, you scroll down, where it says pre-compiled binaries, and you choose Microsoft Windows if you're on Windows, whichever operating system you use. And it's basically just going to be a zip file. Once you extract it, it's just going to be this, right? This single file right here. So now when I have it opened up, and I'll show you how it works. When I have it opened up, all I get is this menu here. I'll click on Open Mesh, choose PLI OBJ, and navigate to the folder where I have my mesh saved from Blender, GUNPLA from Blender. Hit Open. Give it some time to open it up, and there it is, right? So that's the mesh here that I have. So now the thing is, why I'm doing it is because the topology here is basically non-existent, right? And I really don't like it, that it's so triangulated. For this particular project, it's not that important, so I could just decimate it, but might as well use this program to decimate it really well, I guess. So this is a remesher, right? Here in all of the settings is basically 2 steps that you do, or 3 steps that you do. You solve the orientation field, and you solve the position field, and then you export the mesh, right? So let me go through these settings here. Remesh as quads, triangles, right? So you can choose how to remesh, and these are algorithms, right? Or methods, right? So I would suggest sticking to the default one, unless you are going to read through the documentation and on their GitHub and understand what's the benefit between these. So I'm just sticking to the regular one. Then we have configuration details. It's basically going to create a bunch of quads on our mesh, right? This remesher. So in the configuration details, you can specify that those quads should follow the curvature of the mesh. That's extrinsic, right? So for instance, if this shoulder blade bends here, all of the quads will kind of follow that bend. If I have this turned off, it's not going to respect that. So I always have this on. Align to boundaries is basically, right now I don't have any openings in the mesh, but if I had a hole in the mesh, then the quads would kind of very cleanly flow around that hole. But here I don't have one, so we don't care. Sharp creases. This is for like CAD-based design, and this is kind of close to it, because here I do think we will have a sharp crease. We should have a sharp crease, so I'll turn this on. For something blobby, yeah, sure, reload. For something blobby, you definitely don't want sharp creases to be present, but for this model, I do. Okay, and then we have target vertex count. So this is an important one. Before, this mesh had 300,000 polygons. And now it's suggesting that I could get away with 10,000 polygons. I don't think I want that. I want a little bit more. So let me go to like 44,000. It doesn't like that. It can be subdivided to a finer resolution, but any current edits will be lost. Sure, go ahead. Or just waiting for it to do the thing. There we go. Okay, 44k points. It's going to do more, but for now I'm leaving it as it is. And once you have all of this set up, then you just kind of start pressing the solve buttons, right? So I'll press the first one, orientation field, solve. It kind of loads up quite fast, and you end up with these strokes on the mesh, right? And these strokes show the orientation of the polygons, right? How they are going to be created. And you can actually, let me find some sort of a problematic area and try to, yeah, for instance, for instance, this area right here. I don't want the strokes to be across, I want them to kind of connect here. So I will click on this comp tool and I will just kind of draw a stroke like this on the mesh and hit solve again. And then as you can see, it recalculates it, right? So this is a very, very powerful tool. And I want this to go there, solves it again, and does that. So these, and this, I want this to do that. So you can go really deep and kind of go through and control all of the edge flow, the whole edge flow of your mesh. Really strong stuff. But basically, once you're done that, I'll turn off the comp tool. Once you've done that, you can see how many singularities you have. That's quite a few, but we're okay with that. And then you can move on to the next step, which is position field. It actually kind of finds, it places a grid on your, as you can see here, it places a grid on your mesh to determine how these polygons will actually flow. And here I don't really like the flow at all. So since I don't like the flow here, I can just choose this edge brush tool, and I can just specify that no. Here the edges should flow like so, and there we go, and it's going to solve it. That's good. So now they are flowing along the shape a little bit better. Whatever. Right, so now, once I'm happy with how the mesh looks like, I can hit export mesh. And here I have a few options. So right now, I will not choose anything, and I'll just hit extract mesh. And this is how it kind of looks like, and let me turn that off. This is how it looks like. So all of these are polygons. It's like magic, right? Automatic retopology. Swear to God, this is like magic for me. So this is how it looks like now. And some of these polygons, I'm just trying to find. There we go. Some of these polygons are triangles, right? And some of them are quads. So it doesn't. It means it's not. This whole mesh is not a quad mesh, but I can force it to be quad if I choose to tick mark this pure quad mesh, and I click on extract mesh again. You can see it uses Catmull-Clark subdivision to make it into a quad. This is a very shitty quad, but what can you do? So it gets heavier, it gets more subdivided, but I think that's it's definitely worth it, right? So we end up with something like this. Then there's these smoothing iterations. I'll just do 2, or can I do like 10 just to show you how it kind of smooths everything out, right? So this is with 10 smoothing iterations. It's a little bit, a little bit smoother, a little bit nicer. But I'm just double checking if I'm not losing any details. So this is with smoothing iterations 10, and this is with 0. Yeah, we're not losing too many, so I will just do smoothing iterations 5. Just to get some smoother stuff. So now here I can see I do get quite a few details. It's still a little bit bumpy, but definitely not even close to what it to how bumpy it was before. So without any further ado, I will just hit save and choose it as an OBJ file and call it GUNPLA from let's call it IM from Instant Mesh. Hit save. And keep in mind also that when you're saving your file, you need to type in .obj at the end of it and then hit save, and then it's going to actually save it. Because if you don't, then it's going to crash. No, it's not going to crash, but it's not going to recognize what your file format is. So keep that in mind. That's an important thing that I figured out right now. Okay. Besides that, I believe this is exporting right now, so we'll come back once it's done. So now once it's done, we can actually open up Rhino and import it into Rhino. Import file, hit OK. Wait for it to load in, and let's take a look. Of course, it's rotated as per usual. But I believe it's going to be, yeah, that seems to be super. All of the polygons are quads, everything is clean and ready to be used as a model base. So now the next step would be to actually start modeling, but I will not be doing that in this tutorial. We'll do that coming Sunday. Instead, actually, I want to see how this emap, looks like. Where's mesh wires? Turn that off. Select it, weld. And arches. Turntable. Yeah, it's actually not that bad. Okay, sorry, I just wanted to check how well does it reconstruct, how bumpy is it. Basically, I'll show you another approach, and it's all of the steps between the Instant Mesh and Rhino are the same, but it's instead of Blender, you can use Rhino to clean it up. It's just that in Blender it's much faster. So GUNPLA02, this guy right here, I'll choose to import the file, I'll hit OK. And now we wait like for a year until Rhino figures out how to open up a mesh that's 160 megabytes. So while it's doing that, I can close off Instant Meshes. And there we go. So it's opened up. And I will to clean it off, basically you do the same steps as in Blender. So first you get rid of all of the cancel. You get rid of all of the polygons here. So I will use delete mesh faces tool. Select mesh faces to delete, and I'll just select these guys. Hit enter, and they get deleted. Then I select, then I need to repeat the tool. Again, select these guys. Hit enter. It's basically it's basically us going around the whole thing, right? Just like we did in Blender. Actually, I wanna select this whole mesh and just kind of rotate it in place. Not necessarily in place, but just in the at least somewhat correct orientation. So repeat the same command. Oh yeah, and the texture is just basically vertex colors. So it's not like an image texture that we get here, but rather some vertex colors. So I get that. If you want to keep the texture, then you can't remesh it. You actually need to stick to the messed up topology mesh. So I have all of these selected, hit delete, there we go. Delete those. Then once I'm at this stage, I will just say split disjoint mesh and wait for it to split apart. Then holding down the Control key, I'll unselect the biggest mesh and delete everything else, right? Let's see, dupe border. How many borders do we have? We have 5 of them. Some of them are pretty oh, god damn it. So that's considered to be a split mesh, huh? Okay, Control Z, Control Z. Oh, whoops, I accidentally deleted that part. So that was my bad. Doesn't matter. For this particular tutorial, it's whatever. I will select this form here, and I will choose to do smooth on it. And you can see how much by how much it shrinks. It's not by a lot, so this is like good enough. I'll just hit OK to just smooth it out a bit. And that's basically what we end up with, right? I could kind of clean this up even more, but that's whatever. And then I have to choose. I either export this mesh again as OBJ, import it into instant meshes, and kind of do the same thing as we've done before, or I keep this mesh as it is and kind of continue working with it from here on out. And actually, can I just orient 3 PT, first reference point, second, third, and then just kind of orient it somewhere. Come on, just like that. Now this should be flat on the ground. It kind of is. That's good. Gumball should be aligned to world. Okay. So we have 2 options, either this bad boy here or this bad boy here. And don't be fooled by the vertex colors. Actually, can I? Oh, cool. Vertex colors can be even shaded. That's nice. But, and Rhino crashed. Oh my god. Okay, so welcome to, this is going to be fun. Yes, of course I want to send it. So I guess that's it for this tutorial. We will continue on working with that photogrammetry file, from here on out, meaning that I will be uploading this Rhino file that I don't have. Where is it? There we go. Import file. There it is. So I will be uploading this Rhino file together with the base model for you guys to download. You will find that in the video description. And this is just basically so that you can follow the next steps, next tutorials, and kind of then we can share what we did and what we came up with. And I might even print some of your designs if you send it over. Okay, so that's it for today. We have a clean rectangular clean quad polygon mesh. And I will see you all on Sunday. Bye.